dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
And I welcome you to this tutorial, that is our lesson 6. In our last tutorial, we are looking at diffusion in gases. Then today, I want us to look at diffusion in liquids. When you look at diffusion in liquids, it is slow compared to gases, especially if the liquid is still, meaning if it is not moving or flowing, the rate of diffusion is going to be too slow compared to gases. Now I want us to look at how we can demonstrate diffusion in liquids. So what we do, you get a small beaker, you fill that small beaker with a colored solution. In this case, we can use potassium manganate 7 solution. It is purple in color. Then you get a big jar. So you place that small jar into a big gas jar full of water. Then you leave it for a few days. But after a few days, you will see that the purple color will diffuse and spread throughout the whole big jar. As you can see here, this is the purple, the small beaker. As you can see, it is filled with the purple solution. Then after a few days, you can see that the intensity of the purple color is moving up. As you move up, the intensity is coming down, meaning that molecules are diffusing from the bottom going upwards, because this is where we have our potassium manganate solution. So if you don't use that, you can use crystals. Instead of using potassium manganate solution, you just get crystals. These are the crystals of potassium manganate 7, and then this is just water. But after setting up everything like this, you leave them for some few hours, and then this is what is going to happen. After a few hours, you can see that the potassium manganate dissolves and starts to diffuse upwards. You can see the intensity of the purple color goes on decreasing as you move up, showing that the potassium manganate molecules are diffusing from the bottom going upwards. As you can see on the graph, the highest concentration of potassium manganate is here at A, B comes next, up to D. That's why you see we have a negative graph here. Then finally, you'll have a uniform solution. As you can see, the whole solution turns purple. So at this time, it means no more diffusion, because the concentration is the same. There is no concentration difference, no concentration gradient. Then why it takes days for purple color to diffuse throughout the liquid? In other words, we are explaining why diffusion is slow in liquids compared to gases. The reason is that particles in liquids move more slowly than in gases. You remember when we are looking at kinetic theory of matter, properties of molecules in gases, solids, and liquid states. Already we said in gases the molecules are free to move, and in liquids they are less free to move compared to gases. So because they are moving slowly, even the rate of diffusion is going to be low. And at the same time, when you look at liquids, the particles are more close together than in gases. So because they are more close together, there is less space for particles to move. So for particles to move into without colliding with one another. So every time they try to move, they collide with one another, and it slows down the movement. Otherwise, in gases, the particles are spaced. So they have a lot of space. They can easily move without colliding. And then that's why they move fast. But in liquids, because of being close, there is less space. Whenever they try to move, they end up colliding with one another. Then the movement slows down. Then we come to solubility. We have some terms. Whenever we're talking about solubility, there are some terms we always use. One, we have what we call a solute. A solute simply means a substance that dissolves in a solvent. And what does solvent mean? It means a substance that dissolves a solute. A solute is a substance that can dissolve in a solvent, and then a solvent is a substance that dissolves a solute. And then we have solution. Solution simply means that uniform mixture of two or more substances. For example, if you get sugar and you dissolve it in water, you form a solution of sugar. And in that case, water is acting as a solvent because it has dissolved the sugar, and the sugar is acting as a solute because it has dissolved in the solvent. Then that uniform mixture that is formed is what we call a solution. Then we come to types of solutions. We have mainly two types. We have what we call a saturated solution, and this is a solution that cannot dissolve any more solute at a particular temperature. Let us take an example. If you get cold water and begin adding spoonfuls of sugar as you stir, the sugar will dissolve. You add more, you dissolve. So you reach a time when the sugar can no longer dissolve at that particular temperature. Then we say that now the water is saturated. So that solution of sugar will be saturated. Then the second type of solution is what we call a supersaturated solution. This means a solution that has dissolved more solute than it would normally dissolve at a particular temperature. Let us use still the same example of dissolving sugar in water. If you dissolve sugar in cold water, the water will reach a time and become saturated and can no longer dissolve the sugar. And you will see some undissolved sugar in water. So when you warm that water, that undissolved sugar will dissolve again. And even you can add more and dissolves. That means that that water has dissolved now more sugar than it would have dissolved at a given temperature. So we say it is super saturated. So in brief, a supersaturated solution is one that has dissolved more. We form a supersaturated solution after raising the temperature, because when you raise the temperature, the solvent can dissolve more solute. Solubility increases. So we have by definition, we define solubility as the number of grams of a solute that can dissolve in 100 grams of a solvent to form a saturated solution. Is the number of grams of a solute that can dissolve in 100 grams of a solvent to form a saturated solution. So we have the unit of solubility. It's always grams per 100 grams of a solvent, because solubility means the number of grams that can dissolve in 100 grams of a given solvent to form a saturated solution. Solubility is normally affected by one factor, that is temperature. In your homes, you always make sharab, always make tea, but you realize that when you make sharab using cold water, less sugar will dissolve. But if you use water at room temperature, sugar will easily dissolve. So, meaning that as you increase, solubility increases as the temperature increases. That's why even when you have two cups, one cup full of cold water, another one full of hot water, you'll find that sugar will readily dissolve in the cup of hot water than in cold water, because the hot water, the solubility is higher than in cold water. Let us take a look at an example on calculation of solubility. We have this question here where I say that 20 grams of sodium chloride can dissolve in 80 grams of water to make a saturated solution at 40 degrees. So calculate the solubility of sodium chloride at this temperature. Already we say that solubility simply means the number of grams that can dissolve in 100 grams of water. So this is what we do. Already we have seen that 80 grams of water can dissolve 20 grams of sodium chloride. Therefore, we need to find how many grams of sodium chloride will 100 grams of water dissolve. So this is what we do. So if 80 can dissolve this, therefore 100 grams will dissolve X grams of sodium chloride. Then here we just cross multiply. Multiply this with 80 and then we equate it to 100 times 20. So our X end up having 25 grams per 100 grams of water. Let us look at the second example. We have 40 grams of magnesium chloride dissolved into 80 grams of water to form a saturated solution at 60 degrees centigrade. So they want us to calculate now the solubility of magnesium chloride at this temperature. Then already we said that 80 grams of water can dissolve 40. Therefore 100 grams of water will dissolve how many? Will dissolve X grams. So here we just cross multiply. We multiply the X with 80, we equate to 100 times 40, and we end up having our X as 50 grams per 100 grams of water. This statement means that 100 grams of water can dissolve 50 grams of magnesium chloride at 60 degrees. A third example, we say that the solubility of sodium chloride at 60 degrees is 30 grams per 100 grams of water. What is the solubility at 49 degrees? So here we have our answer. Already we said when the temperature is 60 degrees centigrade, solubility is 36 grams per 100 grams of water. So now if I reduce this temperature, that means the solubility also has to reduce. So if I make the temperature 49, what will be the solubility? It will be X. It is unknown. Therefore, I cross multiply this X. I multiply X with 60, then 40 with 36. And then I'll end up having my X as 81.7 grams per 100 grams of water. So we have this assignment which I would like you to try and then submit in the next few minutes. So thank you for watching. Have a good day.